Hi guys, so what we're going to do today is we are going to look at parabolas. Now we kind of have already looked at these, so you're probably going to be a little bit confused, but what we've done so far is we've graphed quadratics. Now a lot of parabolas are those quadratic functions, but what we're going to look at today in addition to the ones we've already done is we're going to look at parabolas that open left and right that are not functions. Specifically these parabolas, we're looking at these in terms of what's called a conic section. Now later on this year, we'll look at some of the other conic sections, but you've actually already learned one of these in geometry. One conic section is a circle. And you'll spend a lot of time on this in pre-calc, but today really what we're going to do is we're going to introduce just some vocab about parabolas and in two new pieces. So what a parabola actually is. A parabola is a set of points that is equidistant from a line and a point. That line is called the directrix, and that point is called the focus. So to help you guys see this a little better, I'm going to show you guys a little applet to help. All right, so what this does, this is going to show you how this parabola is created. So like we said, the parabola is a set of all points equidistant from a line and a point. So right down there we have our line, and that red dot is showing us the point. So what I'm going to do is I'm going to make this pencil move and show all those points that are equidistant from that point and that line. And that is creating your parabola shape. All right, so if I want, I can move that. Let's go ahead and move that point a little bit farther away. And you can see what that does to your parabola now. So it's still plotting all the points that are equidistant, but you'll notice now that parabola is wider. All right, so let me go ahead and move it to where that's going to be a little closer to the line. So very close now. And I'm going to draw the parabola, all those points that are equidistant, and we get a very narrow parabola. All right, so there is a there's a link on Schoology that goes to this site if you want to look at that a little bit more in detail. But that's how these parabolas really are created. All right, so it's all those points that are equidistant from the directrix and the focus. Now within this, there's a couple other little pieces that we're going to look at. One thing we'll use to help us write the equation is a value of p. Okay, so the absolute value of p is the distance from either the vertex to the focus or the vertex to the directrix. So this distance right there, I shouldn't use blue, that blends in. All right, so this distance here is p. This distance there is really negative p. So it's basically going positive is going to go towards the focus, going negative is going to go to the directrix. But the absolute value of p, okay, is that same distance. What that means, your vertex is halfway in between those two things. And every point that's on that parabola, okay, same distance, equidistant from the focus and the directrix. The focus is always going to be inside the parabola, and the directrix is always going to be outside the parabola. All right, then we have another piece of vocab on this. It's something called the latus rectum. What that is that's a chord on our parabola. And what that does is that helps us to find two other points on our parabola. So as you guys know, when we did quadratics, we had to find the vertex and we needed two other points. So the latus rectum is going to be this line right here that I just drew. And then that's going to give us basically two more points that are on that parabola. So it goes through the focus and it's parallel to the directrix. That total length right there is 4p. Okay, so the total length there is 4p. All right, so what we're going to do is look at some things about parabolas, right? So we're going to start with this equation in standard form. There's another form of this equation, okay, and really that is just that equation rewritten. That's the form you may see more often in pre-cal, so I wanted to go ahead and write it on there. But we'll probably use the top equation more often because it looks pretty similar to vertex form, you'll notice. Really, on the vertical one, the only difference between this equation and vertex form is this says 1 over 4p instead of a. And that's really the only difference in the equation. Now, when it's horizontal, though, you'll notice a pretty big difference. So horizontal equations or horizontal parabolas are not functions. Okay, they are not functions. So you'll notice it's x equals y squared. So that's one big difference. And because it's not a function, okay, again, you can have those values repeat. Something else you'll notice in the parentheses, it's y minus k and then the H is over here. HK still stands for the vertex, but that difference in order is something that's really missed pretty commonly. All right, so again, like we said, for both of these equations, HK is going to be the vertex. The distance from the vertex to either the focus or the directrix is the absolute value of P. Okay, if P is positive, then we're going, basically that's the direction we're going in to get our focus, and then we're going outside of it to get to our directrix. If P is negative, that just tells you basically which direction it's going to open. So if P is positive, then if it's a vertical parabola, okay, it's going to open up. We know that, okay? If you have y equals negative x squared, that's going to open down. So a negative value of P opens down, a positive value opens up. Now in terms of these horizontal parabolas, the ones that open right and left, if P is positive, it's going to open right, and if P is negative, it's going to open left. All right, again, with the vertical parabola, just like it was with quadratics, the axis of symmetry is x equals h. Okay, it goes through the middle of that graph. It's a vertical line through the vertex. For a horizontal parabola, it's still going to go through the vertex, but now it's a horizontal line. So it's going to be y equals, and because it goes through the vertex, then it's going to be wherever the y-coordinate of the vertex is. All right, so now let's talk about focus and directrix. So focus is always inside the parabola. Directrix is always outside the parabola. So let's deal with a vertical one first. So let's say I have a parabola that's over here. Okay, the focus is going to be on the inside. The distance between the focus and the vertex is P. So if let's say I know the vertex, because if I have the equation, I'm going to know the vertex. The x-coordinate from the focus to the vertex has not changed. So the x-coordinate of the focus is still going to be h. The y-coordinate, though, has changed. It's changed because we're adding the value of P to it. If P is negative, we're still adding P to it. But if it opens down, the focus would be on the inside. All right, the directrix. The directrix is a line. It's a horizontal line, so it's a y equals line. Again, if it opens down, then what we'll do, do k minus P. And, sorry, I said it opens down. If it opens up, well, either way, we're going to do k minus P. If P is a negative value, well, then I would do k minus a negative 1. It would be k plus 1. So it's minus P, basically, if it's in order to find our directrix. If you're more of a visual person, that can make these a little bit easier, okay? What you want to remember is that the focus is inside, the directrix is outside. How far away it is from the vertex is the absolute value of P, all right? Whether or not P is positive or negative, that helps us determine which direction that this is going to open. All right, now let's look at these left and right parabolas. So let's say we have one like this over here. Okay, here's my vertex. The focus is going to be on the inside. The x-coordinate has changed. The x-coordinate has changed by the value of P. The y-coordinate has not changed. All right, on this one, the directrix is going to be a vertical line. Vertical lines are x equals. It's changed, the x distance has changed from the vertex. So, I don't know why I wrote P first. I would subtract P. Okay, again, if P is negative, well, that means my graph would open this way. And if you subtract a negative, you're adding, so you're moving in the correct direction. So it still works out. All right, and then again, that lattice rectum, okay, the total length is the absolute value of 4P. That point goes through the focus, and that helps us find 2 more points that are on our parabola when we're sketching our graph. All right, so what I want to show now is how we get this 1 over 4P equation, because that's what we're going to use for this focus and directrix. So in order to figure out where this comes from, we're going to use the distance formula. So I'm going to start by just drawing a parabola. We'll do a sideways parabola. All right, so there's my parabola. We'll go ahead and draw the focus and the directrix. So here's my focus, here's my directrix. Okay, let's say the vertex here is at 0, 0 to keep it simple. that means that the focus over here, the distance between the focus and the directrix is p. So that point would be p comma 0. All right, this line would be x equals negative p, because again, that distance is p. Since it's the directrix, it's away from it, so it's going to be x equals negative p. All right, so what we'll do is let's take some random point that's on this parabola. Okay, let's say we're going to take this point right here. Okay, well, every point on that parabola is equidistant from the focus and the directrix. Now, obviously, this is not a very scale drawing, but that's okay. Pretend that those are equidistant, because that's what it should be. Didn't do a very good job drawing my picture. Sorry about that. So what we'll do is let's go ahead and actually find that distance. Okay, using the distance formula, and actually I'll write it down here. To find that distance, what I would do is the square root. Okay, what I know about that point, we'll call it xy. So if that point is xy, the point over there that it's equidistant from, we know it's going to have the same y coordinate. We also know that that x coordinate there, because it's on this line, that x coordinate is negative p. So that point right there that we're finding the distance from, that would be negative p comma y. So we're trying to find the distance between negative py and xy. Well, to find that, I would do x minus negative p squared plus y minus y squared. That's your distance formula. Well, if I go ahead and try and simplify that, then I would get the square root of x plus p squared. And I could go ahead and just write this as x plus p. I'm going to leave it like that, though, just because this next one's going to end up as a square root as well. And having those equal makes it a little bit easier. Okay, so we found the distance between the directrix and your point. Well, now let's find the distance between the focus and your point. Okay, well, the focus is at p comma 0. So this would be x minus p squared plus y minus 0 squared. So this becomes the square root of x minus p squared plus y squared. Okay, so now we have our two distances. Well, what we know about every point on this parabola is that those two distances are equal. So that means that the square root of x plus p squared is equal to the square root of x minus p squared plus y squared. All right, so now I can just rearrange this equation, and this is how we're going to get it into that other form. If I square both sides, those square roots go away. So I'm left with x plus p squared equals x minus p squared plus y squared. We'll go ahead and FOIL those out. Remember, you don't just square the individual terms. So I get x squared plus 2px plus p squared equals, and let me erase this now so you guys can just see this a little bit better. You have a little bit more space on your paper. All right, that's going to equal x squared minus 2px plus p squared plus y squared. All right, so now at this point, all right, if I'm just going to try and rearrange this equation, we'll go ahead and get our x by itself. So this is a sideways parabola. All right, so since it's sideways, it's going to end up in the form of x equals. So x squared, if I subtract it from both sides, that goes away. P squared, subtract it from both sides, that goes away. If I add that 2px, add that to the other side, I end up with 4px is equal to y squared. To get x by itself, divide by 4p, so 1 over 4p y squared. And that's my equation. We know that's right because the vertex is at 0, 0. So that's really where it comes from. Again, you don't really have to know all that, but I know some of you guys sometimes like to see that we're not just throwing these things out of thin air. All right, so when it comes to actually looking at these, again, sometimes it helps just to draw the graph and kind of look at it that way. So what we're going to do is we're going to graph this parabola, and we're also going to graph and find the focus and the directrix. So this is one you've already done before. Okay, you can graph this using transformations if you want to, but we're going to use this new information to help us find the focus and directrix. So we'll start with vertex. Vertex here is 1, 5. So I'm going to plot 1, 5 first. We know this graph is going to open down because that value is negative. All right. The axis of symmetry, because it's vertical, x equals the x-coordinate of the vertex. So nothing there has changed. All right, so now let's talk about focus and directrix. To find focus and directrix, we're going to start by finding the value of p. If 1 over 4p is equal to a negative 1 over 12, well then p is obviously a negative 3. So what that means, we're going to move 3 away from the vertex to get to the focus and the directrix. The focus is inside the parabola, the directrix is outside the parabola. So since this opens down, we're going to go 3 down to plot the focus. We're going to go 3 up to get the directrix. And remember, the directrix is a line. That means that the focus is at 1, 2. The directrix is the line y equals 8. Then to finish our graph, we'll use the latus rectum. The length of the latus rectum is the absolute value of 4p. So that means it's going to end up as 12. So the total length of this line that goes through the focus is a length of 12. If the total length is 12, I'm going to go 6 in each direction. So those are the 2 endpoints of the latus rectum. That's the 2 points I need to continue drawing my parabola. All right, let's look at one that opens left and right. So again, this is x equals and y squared. So we know it's going to open left or right. The p-value is positive. Okay, specifically, if 1 over 4p is equal to 1 over 8, p is 2. So this is going to open to the right. The vertex, be careful. Remember, this is in the form of y minus k plus h. Your h and k are flipped. Okay, the y coordinate is next to the y. So your vertex here is negative 1, negative 2. Probably the most missed thing on these parabolas is the vertex of these sideways opening parabolas. So negative 1, negative 2 is my vertex. Axis of symmetry is going to be a y equals line, and it's the y coordinate of the vertex. Since it opens right, the focus is going to go to the right of the vertex. We're moving a distance of 2 to the right. Directrix will be outside, still moving a distance of 2, making a line. So the coordinates of the focus were 1, negative 2. Directrix was x equals negative 3. To get the other 2 points on our graph, we'll find the latus rectum. Absolute value of 4p is 8. So total distance is 8. That means I'm moving 4 away from the focus to get those other 2 points. And there's my right opening parabola. All right, if you feel comfortable, pause the video, try the next one. You'll notice the scale is a little different to hopefully make that one a little easier. All right, so again, you guys could graph this just using what you guys know about transformations. But to find the focus in directrix, okay, we need to consider again what the p-value is. So 1 over 4p is equal to 1. That means that 4p is equal to 1, so p is equal to 1/4. This graph is going to open up because it's y equals x squared, and it's a positive p-value. The vertex here is 0, 1. Axis of symmetry, since it's vertical, will be x equals 0. All right, and then we're going to go ahead and plot our focus and our directrix. So we're going to go up, because it's opening up, a distance of 1/4. Okay, so a quarter of the way there. And then there's our directrix. Doesn't have to be exact, but we're writing our coordinates. So our focus, we've moved up a distance of up a distance of 1/4 from 1. So 1 plus 1/4 would be 5/4. We've subtracted a distance of 1/4. Oops, sorry, that's going to be y equals. So y equals 3/4. Absolute value of 4p is just going to be 4 times 1/4, which is 1. That's the total distance. So from the focus, I would move a distance of 1/2 to get those other 2 points. Now, if you were graphing this, again, you can graph this the same way we graphed it on the first day, but knowing how to find that p-value helps us find our focus and our directrix, and that's kind of the big thing here. All right, so now we're going to go backwards. So now we're given the focus in Directrix. We're going to sketch the parabola, and we are going to write the equation. So we'll start by graphing the focus. So -2, 0 is the focus. Y equals 4 is the directrix. So remember, the vertex is halfway in between those two things. And your parabola is going to open away from the directrix and towards the focus. So that means we're not going to cross the directrix, so this has to open down. Vertex is halfway in between, so halfway in between is going to be right there at -2, 2. All right, so if that's the vertex, then the distance between both of those, the absolute value of that distance is 2. So the absolute value of P is 2. Since it opens down, P is -2. Latus rectum, absolute value of 4P, so that's going to be 8. So to get those other 2 points, I would have a total distance of 8 from the focus, so I'm going to move 4 in each direction from the focus. And I missed my point. So now we have our graph. So now let's work backwards and write the equation. Y equals 1 over 4P x minus h squared plus k. We now know the value of P. It's a -2. And then the rest of it is just like it was for your regular quadratics. All right, if you feel comfortable, pause the video, try the next one. All right, focus is at 2, 0. Directrix is x equals -2. It's a vertical line. So since directrix is a vertical line, our focus is going to the right. This is going to open right. Vertex is halfway in between them, which is at 0, 0. All right, since that's my distance right here between those is 2, it's opening right, so my p-value is 2. That means the latus rectum, absolute value of 4p is going to be 8. Total distance of 8, so I'm moving 4 in each direction from the focus to get my other 2 points. And there's my parabola. Since we're talking about horizontal, x equals 1 over 4p y minus k squared plus h. So x equals 1/8 y squared. All right, so the last thing that we're going to do is we're going to look at some of these that aren't starting off in that nice, easy standard form. So in order to get them in that nice, pretty standard form, we have to complete the square. All right, so compulsory completing the square would not go away. When you guys do get to conics later in this year, but also in pre-cal as well, you spend a lot of time with conics, you will need to use completing the square to write those in standard form. So make sure you understand it. All right, so since we're dealing with completing the square, the first thing we probably want to recognize is, hey, is this going to be a horizontal or a vertical parabola? And we can tell by identifying what's squared. Since y is squared, it's going to be x equals y squared. This is going to be a horizontal parabola. So a lot of different ways you can do this. I'm going to try and get this kind of in my standard form, so I'm going to kind of set it up to make it a little bit easier for that. So that means I'm going to go ahead and take this -12x, and I'm going to go ahead and move that to the other side. Because I know in standard form for a horizontal parabola, it's going to be x equals 1 over 4p y minus k squared plus h. So I'll do y squared minus 4y. I'm going to go ahead and leave my blank. And I'm going to move that 12x to the other side. To figure out what goes in that blank, now if there's a blank on the left side, there's also going to be a blank either on the right side, but that's not really going to help me. So I'm going to subtract that same number to keep this balanced. All right, so now let's figure out what goes in that blank. Take the b value, divide it by 2, and square it. So -4 divided by 2 squared is 4. If you add 4 to the left side to keep it the same equation, you also have to subtract 4 from the left side. I've now created a perfect square trinomial. That becomes y minus 2 squared. 64 minus 4 is 60. Then at this point, to get it in that, get x by itself, I would divide everything by 12. Do not just put a 1 over 12 here. You have to divide the entire thing by 12, including the 60. which means what this equation is going to be, when it's in that correct form, it would be 1 over 12 y minus 2 squared plus 5, because we've also divided that by 12. All right, so to graph this, if you feel comfortable, pause the video, graph it on your own. All right, vertex here, be careful. 5, 2 is your vertex. 5, 2 is the vertex, HK. Then your p-value here is 3. It's horizontal, it's going to open to the right. So I'm going to go 3 to the right of the vertex to get my focus. 3 to the left to get my directrix. Absolute value of 4p is 12. So I'm going to move 6 up and 6 down. To get my parabola. All right, the other thing it asks us to do is to go ahead and graph the inverse. So to graph the inverse, we switch x and y. That also switches x and y for the focus and directrix. So if my directrix was x equals 2, now it's going to be y equals 2. Vertex was at 5, 2, it's going to be at 2, 5. Focus was at 8, 2, it's going to be at 2, 8. Those other 2 points that were there, I had 8, negative 4, so I'll go to negative 4, 8. And 8, 8 will still be 8, 8. So there's my inverse. All right, last one. If you feel comfortable, pause the video, try it on your own. All right, so what we're going to do here, I'm going to rearrange this. I'm going to go ahead and move that y to the other side because I know this is going to be a vertical parabola and y is going to need to be by itself. So x squared plus 8x plus blank minus 48 minus blank equals 16y. Number that goes in the blank, 8 divided by 2 squared is 16. That's a perfect square trinomial. Negative 48 minus 16 is going to be a negative 64. Divide everything by 16. And my equation is in standard form. All right, so vertex opens up. This is going to be negative 4 for a vertex. P-value here is 4. It's going to open up, which means that my focus is going to go up. Directrix is going to go down. Lattice rectum is 4p, which is 16. That means I'm going to move 8 and 8, so I'm going to be off my graph a little bit, but that's okay. To graph the inverse, switch x and y. So still negative 4, 4, but your directrix now is a vertical line. And then you've got 0, one of those is off the graph, but 4, 0 is now 0, 4. And the rest of it's going to go off your graph a little bit. So now to write the inverse, okay, pretty simple. We switch x and y like we talked about. So the original equation, that would become y equals 1 over 12 x minus 2 squared plus 5. And that is the equation of this parabola. And that kind of looks like a baseball now. Over here on B, switch x and y. X equals 1 over 16, y plus 4 squared minus 4. Now what you'll notice on the second one is that your inverse is not a function. And what we're going to talk about later this year is how to find the inverse of a quadratic so that the inverse is a function. But we're going to wait to get that until probably next semester. All right, so that's it for parabolas. So again, the big thing for today is identifying focus and directrix. So those are really the two new pieces. And then also graphing your horizontal parabolas.